Hello and welcome. I'm Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. Today is another series, and this one is going to be predicting the March Madness brackets. Now, for those who don't know what March Madness is or don't really watch basketball, March Madness is this massive tournament where a whole bunch of D1 schools for basketball get together and they compete to try to be the champion of the tournament. Now, a lot of data analytics and prediction goes into trying to predict who is going to be the winner of the tournament and trying to predict every single game all the way down to the championship game. Now, no one has ever predicted an entire bracket accurately. There's always a couple games that are off. So it's still an open problem, and a lot of people are trying to solve this. Also, basketball and just sports in general tend to have a ton of data surrounding it, so it's very ripe for using machine learning techniques and analyzing the data. So that's what we're going to be doing. Without further ado, let's go ahead and just start tearing apart the data, seeing what we can come up with, and building out our models. All right, swapping over, you can see, very first thing I have up here is the link to the data. Now, Kaggle is if you haven't used it before, it's a site where there's a lot of competitions and a lot of data sets that are available to do some of these machine learning tasks. They actually have a yearly tournament to try to predict the March Madness brackets. So, again, this year there's another one. So go ahead and jump over to this link, download that data, and we can go ahead and get started. Now, these data sets are actually they've done a lot of the pre-processing for you, and they have they've put a lot of work into making these data sets pretty nice to use. So definitely recommend going in and downloading those. As you can see on the left side of the screen, I have all these downloaded. There is quite a few files that they give you. We're definitely not going to be going through all of them. Some of them aren't going to be relevant for the things that we're going to be doing, and we're not going to dive too deep into using some of these values that they have. So we're going to go through some of them, and I'll tell you which ones that I'm actually using as we get there. But again, go ahead and just download this. Like always, first thing we need to do is we need to start importing some packages. So we're going to be importing pandas as PD. Go ahead and import NumPy as well. And the last one is going to be matplotlib.pyplot as PLT. Go ahead and run that. Like always, if you aren't familiar with any of these, I have series that goes over how to use each one of these. So definitely useful. But for now, we're just going to use basic functions on these, so it's not too important to understand them. Okay, so I'm going to define a folder because I put all of these into a folder once I unzipped it. And that folder is called mdatafiles_stage1. Now, if you download the zip file, yours is probably going to be called the same thing. If not, go ahead and just link this to wherever you put them all. Okay, first thing we need to do is we need to import some of these CSV files that we're going to use. So I'm going to use 4. We're going to start with, we're going to need the seeds. So whatever seed each one of the teams is within the tournament. We're going to do a pd.read CSV. We're going to take that folder where they're all stored in, and we're going to add in what the file name is. So this one is called NCAA tourney seeds.csv. You can just go ahead and display seeds, show you what that looks like. And you can see it's just what season it was, what the seed was. We'll get into what each of these letters and numbers mean in a second when we actually start splitting those out. And then we have a team ID. Now the team ID is actually important. Kaggle has put together this so that each of the teams have a unique team ID so that you can reference each one of them across the data sets. You don't have to worry about different spellings of the team names and a whole bunch of other stuff. So makes it super easy. And you're going to see that come up pretty much in every single data set. Next one, each team is in a conference, so it'd be nice to know what those are. So pd.read CSV folder plus this file is called mteamconferences.csv. Should have kept that display, but let me go ahead and display this one as well. Okay, as you can see, season, team ID like the other one. Instead of the seed in the last one, this one is now the abbreviated name for whatever conference that they're in. So this will be useful for just trying to link teams, figure out which conferences are there, and maybe even determining which are the best conferences and using that as a variable. So, and now the next two are going to be the biggest workhorse for all of the data that we're going to use here. So first one is, we're going to call this regular detail. You're going to see why in a second. That's going to be pd.read CSV folder plus. Okay, now this one is called regular season detailed results.csv. Hopefully I spelled everything right there. And I'm just going to display regular detail. Okay, now you can see this has a ton of information in it. Season, the day, so this is there's a specific day that each of the seasons start, and this is how many days from that this game is happening. It has the ID of the team that won this particular game, and it also has the ID of the team that lost, how much they each scored, and a whole bunch of statistics on what happened in that game. So we're going to be using this to get the majority of our data. Now, the reason this is called regular season is because this is all of the games leading up to March Madness. So these are not going to include any of the actual March Madness games from past tournaments. So if we go ahead and copy this, we can actually get those past tournaments by doing, I'm going to call this tourney, let's call this one compact. We are going to be replacing all of this with NCAA tourney compact results. Okay, so difference between detailed and compact is fairly obvious, but the compact versions, there is also a regular compact and there's also a tourney detailed, but it just it doesn't have all of these different statistics for each of the games, and I don't necessarily need that for the past tournaments. So let me just print this to show you what they look like. And again, it's super simple. Season, what day was played on, which team played, or which team won, which team lost, what the score was, where they were located, and if they went into overtime or not. So if you did the detailed version, it would have all those other statistics that we just looked at, but we don't necessarily need to see those right now. Okay. I'm going to, just for reference, because we probably are going to be going back to this regularly, I'm just going to display the regular one, just so I can see what all of the fields are to reference those. Okay, now is where we are going to start breaking this down. So what we would really want to do, so again, this is regular season, and we are going to be predicting the data starting from the end of the regular season. And so what would be very helpful is if we could start looking at these statistics over the entire regular season leading up to each one of the tournaments. So we're going to be looking at the season, so whatever year this happened in, and then we're going to be grouping by whatever team that we're trying to look for. Now, the problem is there are winning team IDs and losing team IDs. So whatever team we're looking for could be in either one of those. So we kind of got to generalize it, and we got to kind of swap IDs here. Let me just create another cell and we can start doing that. So I'm just going to make two blank data frames. We're going to call this one win teams. That's going to be equal to pd.dataframe. It's just going to be empty, and we're going to do the same thing for lose teams. That's going to be, again, pd.dataframe with nothing passed into it. Okay. I am going to do one thing here. I'm going to print out the column names, because that is what we're going to be referencing here, and it's just going to make it easier, and it's in an array. So we're going to make a variable called columns. And this is going to hold all of the columns that we want to preserve in the end. So I'm going to copy all of these as just a starting point, and I'm going to pass these down. Another good reason to print those out is because they're already properly formatted, and we can just pass those in easily. Now, we're going to keep the season. Day number is not going to matter because we're going to just group all of them per season instead. Okay, so what we're really trying to do is I want a single line to be for unique to one season and one ID, right? So we're going to, instead of calling this win team ID, we're just going to say whatever team ID is in the win column, that is going to be the one that we're making this for. So we're going to call that team ID. Now we can go ahead and just, I'm actually, instead of score, I'm just going to call this points. And this is going to be the points associated with the winning team. In this case, this is the team that we're going after. Okay, so now losing team ID is the one that they played. I don't necessarily care to keep that because, again, we're going to be summing all of these, and it does not matter who they played. What does matter is sort of this the summation of the stats over the entire series. So don't need the opponent's ID. We do want how many points the opponent scored on our team that we're looking at here because we kind of want to see how many points they let up over the entire season. So I'm going to call this op points for opponent points. Okay, we do want to know the location because there is likely a statistical significance between playing home versus away for as far as the number of wins. So we're going to keep that. We're going to keep the number of overtime just to keep track of how many times each of these teams go into overtime. Okay, so now every time we see a win here, this was associated, the W is for the winning team ID, so the winning field goals made, that's what FGM is. And so it's no longer the winning team, it's just whatever team we're looking at since we are picking out the winners. So we're just going to call this field goals made. So everywhere you see a W, just go ahead and remove it. And a couple more here. Okay, so go ahead and just remove anywhere where those are W's. And now we're gonna, instead of loss, it's going to be just the other team. So like I have up top, I'm just gonna change all the L's to opponent. So put OPP there. Make this go a little faster. And 3 more. Okay, so that's going to take care of all of the, hopefully all of the things that we're looking for. And so these are going to be our end columns that we're looking for, but they do not match what is in our data frames currently. So we're going to have to go through and manually move all those over. But what we're going to do is we're going to say win teams. We're going to pass in those columns. So we're just creating the data frame now. So we're passing in the columns, and now we're going to start assigning what those values are. So we are going to take the regular detail at, now if you do a double bracket, that is how you can reference multiple columns at one time. So again, we're going to take and copy all of these columns up top here and go ahead and pass those in. And now we have to remove all the ones that we did before. So we have, let's see, we have the season. The win team ID is going to be associated with our actual team ID. We have the score for the amount of points. We don't need the losing team ID. We do need the opponent's score, and then I believe all of them are in the proper order for the win-loss, so we don't have to worry about that. So this one should take care of it. And there's a couple other things that we do need to know. I didn't actually close out my brackets here, so go ahead and do that. Okay, so again, this is in the format where whatever team that we passed in as the actual ID, the second value here, was the one who won it. So we need to keep track of that they were the one to win it. To do that, I'm going to say if the team that's in this team ID won it, we're going to give them a 1. And if they lost it, we're just going to keep it a 0. So we're going to say win teams for wins, I'm going to make a new column called wins. That's going to be equal to 1 because every single time that our team ID is in this team ID for this specific data frame, they always won it and they never lost it. So I'm actually going to make another column. Just go ahead and copy that down. And instead of wins, we're obviously going to call this losses. And they did not lose, so make those zeros. Okay, so that takes care of all of the instances where the team ID that we care about was in the win team ID. Now we need to do the opposite, and we need to figure out where the team ID is in the loss team ID. So go ahead and copy everything we did here for the win teams, because we're going to do the same exact thing for the lose teams. Go ahead and call that lose teams. Now, it's going to be very similar to what we did. Unfortunately, a lot of these wins and loss IDs are going to need to be switched. So basically everywhere it says W, we need to switch that to an L, and everywhere it says an L, we need to switch it to a W. Because again, we are swapping the location of that ID. This may take a second. All right, now we got to place all of the L's with W's. Try and do this as fast as I can here. This goes a little faster. Okay, so this is going to take care of all of our winners and our losers. Now, we want to merge those two together so we have one massive list of all the team IDs and what they did per each game. Actually, there is one more thing that we missed. Let's see. This location is actually... Let me compile this to make sure I have no errors. But this location actually needs to stay win location because there is no lose location. And so what we need to do is we need to just create a function to swap that. So we're just going to create a function called change location. We're going to pass it in location, and it's just going to be a bunch of if-else statements. So if the location equals H is for home. So if they were playing home, now this is if the winner was playing home. So if the winner was playing home, then the loser was playing away. So we need to return away, so A. Else if the location equals away, we need to return home. And then there are also instances where it's an N for neutral, which means that they were neither home or away, they were playing somewhere else. So we're just going to return N for everything else. Okay, so that's our function. Now we can just apply that by coming down here, saying lose teams at location is going to be equal to lose teams at location dot apply, and we're going to apply this function. So we're going to apply change location. All right, what this is going to do is it's going to run through the entire data frame for this column, and it's going to pass everything through this function that we created, so it will flip every single one of the home and aways for us. Okay, that takes care of location. Just like we did up top, we need to change the wins and losses. Now, since the ID that we care about for this specific one is the loser, they did not win, so pass in zeros for the wins and pass in 1 for the losses. And that will take care of all of our winners and losses. Now what we can do is, let's just call this a win-lose teams. What we're going to do is we're going to combine these. So we're going to do pd.concat. We're going to take in win teams and lose teams. And this is going to merge those together. So let me just display this to make sure I have no errors before I do the next part. And it looks pretty good. Okay, so as you can see, all of our data here, it's hard to tell, but as you can see on the left here, we have the top half, it looks like, is when the wins are ones and the losses are zeros, and the bottom half is zeros and ones, which means we just stack the wins on top of the losses. So perfect, exactly what we wanted. So this is still game by game. Now what we want to do, since we have these all split out and the team IDs are correct, is we want to group these by whatever season it is and whatever the team ID is. And then we want to sum all of the different columns. So I'm just going to call this, let's go with combined teams is going to be equal to win, lose, teams. We're going to do a dot group by. And then we need to tell it what columns we want to group by. So I want to group by season, and then I want to group by team ID. And now we need to tell it what we want to do with each of the columns. So we're just going to sum each one of the columns. Going down here, let me just display what I did. Combine teams. Okay, as you can see, season and team ID moved over to be our index, and now it's just grouped by season, and then each one of the team IDs has its own individual line within the season. But you can see it's just the summation across all of these, which is good. And we're going to get into some other problems with this, but one thing that would be useful is to know, so if I come over here, so FGM is field goals made, so how many times they made a basket. Now, 536 may be good, but it really depends on how many games they played, because it's not guaranteed that all of these played the same amount of games. So we want to know what was the average field goals made per game. So what we have to do is divide it by the number of games. So we need that variable. So in combined teams, we're going to make a new variable called num games. And this is going to be equal to, I'm going to copy this. It's going to be equal to the wins plus the losses. The number of wins plus the number of losses. Go ahead and just do summation of those two, and that will give us, if you run this again, we now have num games to see how many games each one of these teams played. Okay. That pretty much gets us to the point where we can now start making useful features from this. And so I'm going to jump down and let's see. Yeah, I'll keep it up on the same one, actually. Okay. What we need to do is now we need to start doing exactly what I was saying, where we have a lot of these features, but we need to make them comparable to each other, because like points scored, you may have more points scored because you played more games rather than you just were better. So we need to start building some of those out. So actually, you know what? Just make it cleaner. I am going to do a second line here. We're going to call this one regular season input, saying that this is into our final algorithm or final data set. This is going to be all of our regular season data. And just like before, we're just going to do a blank data frame. Okay. And now we're going to start going through each one of these. I'm going to try to keep this up here, keep referencing back to it. So first thing that's going to be super useful is going to be the win ratio, right? So I want to know if the team is winning more or losing more. And so we're going to call this regular season input. We're going to make a new column in here, and this is going to be called the win ratio. And this is going to be equal to combined teams. That's what we called it up here. Okay. It's going to be equal to the combined teams. It's going to be the wins divided by the total number of games. So combined teams, I have a hard time spelling that, at num games. So how many wins do you have versus how many games you played? You should be greater than 0.5 if you are a winning team. Okay, that works for the first one. Now we're just going to kind of run through each one of these and kind of build out our own. And now you can't really see all of the names here, so we're just going to print out the column values just to make it a little easier. And we're just going to kind of run through the list from start to the end. So I'm actually going to copy this line because it's pretty much going to be the same formula for a lot of these, but we're just going to change what we're calculating. So I'm going to call this one points per game. Let me just capitalize this, I guess. I'll do camel casing. Points per game. So how many points we scored, I called this one points per the number of games. Fairly simple. And that should tell you how much a team is scoring on average in every game. But there's other things we can do with that. So not only do I want to know how many points on average we're scoring a game, but I would also like to know how many points on average they're losing a game. So I'm going to call this one points allowed per game. And this is going to be the opponent points over the total number of games. Let me just display this so you can see it building out as we go. Regular season input. Okay, so as you can see, we have 3 variables that we're just slowly building these in, 3 columns. So win ratio, points per game, points allowed per game. Now, I would also like to know the point ratio. So it's kind of comparing the two that we just calculated almost. So I'm going to copy the one we just did. I'm going to call this one points ratio. Okay, so this is going to be the total number of points that we scored in the entire season. We as in whatever team that we're looking at right now. Versus however many points the opponent scored. So this is going to be op points. And this is going to just show you the ratio of points for versus points allowed. I do have an error, so I must be missing something here. Opponent points with an S. Okay. You can see it should be 1 if you scored the same amount that your opponent did. And it should be higher than 1 if you are outscoring your opponents on average over games. So as you can see, it's hovering around 1. Some of these teams are below 1, which means they allowed more points to be scored on them than they actually scored. But just another indicator that we could use. Okay, continuing down our list, we took care of points. Now we have number of overtimes, so this should be just a simple number of overtimes per game. I'm going to steal the very first one that we put together, and we're going to call this one OT per game, or I guess I'll call this OTs with an S. Doesn't really matter. What we're pulling from is num OT, so the number of overtimes per the number of games played. Column added. Okay. Now we get into a lot of the point scoring ratios and how well the team is able to convert. So go ahead and just paste another one in here. I'm just going to separate this because there's going to be a lot of these that are the same. So FG, which is the next one in our list here, is field goal. So this is just a, I believe just field goal is any basket they made. So we're going to say field goals per game. Again, just a simple, this one is called FGM for field goals made. So just field goals made over the number of games. Now, that gives us something, but another useful metric, I'm going to capitalize this P real quick. Okay, so another useful metric would be how often they can convert a field goal. So if you throw 1,000 shots, but you only hit 50 of them, that's not a very good ratio if you threw 1,000, but you hit 800 of them. So we're going to call this FG ratio. This is going to be equal to the field goal made. So how many times you made it versus how many times you attempted, which is FGA. as the next one on the list. So just how many times you attempted to shoot and how many times you made it. Okay. I'm going to copy the very first one. So this is how many times you made a basket. But I would also like to know how many times your opponent did. So field goals allowed per game. This is going to be, I believe this is called opponent field goal. Just making sure. Yep, opponent over the total number of games. And this is going to take care of all of your field goals. Now, there's a second set, which is field goal made 3 and field goal attempt 3. Now, this is if you made a 3-point shot. So we're basically just going to copy all 3 of these because they're going to be the same exact ratios that we're going to want to calculate. But instead of each one of these, we are going to call this, just call these field goal 3 per game ratio and allowed. Let me just space this out so you can kind of see each one of these. And then each one of these, it's the same name except for 3 is just at the end of it. So go ahead and add those in. And you can see on our data frame, we have all of these in here now. Okay, takes care of a lot of those. So we're done with the first line. Now we're on to free throws. We could do the same for this one. Yeah, let's go ahead and do the same. Go ahead and copy the 3 that we put together for that one. We're just going to run through the same one. So everywhere it says FG3, just replace that with free throws. So FT, FT, and FT is actually FTM for field goal, for free throws made. And then it's FTA for free throw attempts, and then it's opponent FTM for free throws made over games. Okay. Hopefully you followed through all that. Basically just replaced FG3 with FTM for made and FTA for attempts. All right. Moving on. So that takes care of all of the shots. Now there's other things that we need to know, which is this is offensive rebounds. So how many times when you shot you were able and you missed, you were able to recover the ball. And defensive rebounds, which was how many times the opponent shot and you were able to recover the ball. Theory being that if you recover a lot, then you have possession of the ball most of the game and you would be a better team. Or you would be higher likelihood of winning, I guess. I'm going to go up to the top and, again, just steal that first one. But we're going to call this one, we're going to look at the offensive rebound ratio. Okay. So, thinking about this a little logically, when either you shoot or your opponent shoots, 2 things can happen. If you are shooting, either you are going to recover it, and that is going to be an offensive rebound, or the other team is going to recover it, and that's going to be a defensive rebound for them. And the opposite is true for when your opponent is shooting. So I would like to know the ratio of how many times in each one of these scenarios. So pretending that this team has the ball, they shoot. What is the ratio of the amount of times that you were able to recover the ball versus when your opponent was able to recover it in each one of those scenarios? Okay, so this is going to be offensive rebounds. And then we're going to say that is equal to the number of offensive rebounds plus the other scenario where the opponent recovers the ball. So this is going to be equal to the opponent DR. Again, this is just comparing how many times you were able to recover the ball over the total number of recoveries. So either whether you did it or your opponent did it. And this will give us a ratio of how well you're able to capitalize on that. Next, it's going to be the same thing. We're just going to replace these with defensive rebounds. So throw in DR there. And now it's going to be equal to the opponent's offensive recoveries since they're the ones shooting in this scenario. Okay. Going back to the top, we are getting close to the end of the line here. So we have assists next. So we're just going to do a simple assist per game. Again, copying that first line just to not have to type everything out. We are going to call this AST per game. Go ahead and pass in AST and over number of games. I could do it for the opponent as well, but it doesn't really matter. I'm just going to keep it as just for the current team that we're working for. If you want to, go ahead and throw that in. Doesn't really matter. Okay. Now is... Okay, these are all sort of related. So this is equal to turnovers. So maybe double dribbling or traveling. You just give the ball to the other people because you did something. Stealing is where the opponent is able to take it from you. And blocking is where the opponent blocks you when you're trying to take a shot. And the last one is personal fouls when you accidentally foul another player. So these are all related to how well your defense is doing. Each one of these, the turnovers is how many times your defense was able to turn over the ball. Same with steals and blocks. So we're just going to do simple, just like the last one we did down here. We're just going to do simple. How many do you get per game? I think there were 4 of them, so I'm just going to copy this down 4 times. And it's going to be equal to the turnovers per game. That's going to be the first one. Second one is going to be steals per game. Then it's going to be blocks per game. And the last one is personal fouls per game. Go ahead and fill in each one of those. BLK and personal foul. And running it. Okay, so again, I could do it for the other team if you really wanted to. I'm just going to keep it for the current team because this isn't as... I wouldn't think it would be as relevant as like the amount of points you scored on you or whatever. So, and also if I used it on the opponent, it would say more about how, which I guess could be useful, but how strong your opponents were on defense, which the model may find interesting, but I'm just going to leave it at this for now. And that actually is going to be pretty much everything we do for this. Go ahead and compile it, make sure you have no errors, and scroll over. You can see we have a whole bunch of data here. So a lot of good ratios that we can use. I'm going to do a dot describe. I want to see some of the maxes, mins, see if we have any missing values, all sorts of stuff. So you can see the mins, maxes. Now I don't want to see something where it's like 0.00001 and then the max is like 1,000. I don't think we're gonna have anything close to that. It's all looking fairly similar, so we're looking really good for this one. Yep. Okay, and I don't see any not a numbers or infinities, so we should be good on that. We don't have any missing data. Another thing you could do is in the statement you can do is NA, and then you can do a sum. This is just going to tell you how many not a numbers you have. And in this case, everything we have is full. So don't have to worry about that. Okay. Just going to print this out because we may need references again. All right, so that's everything we need to do for the regular season. Now we have something where we can reference and say, hey, I want to know what Team ID 1106 did in 2003. And this is just going to pull all of their stats. And then what ultimately we're going to do is, in each one of these tournaments, in this next part, you're going to have 2 teams pitted up against each other. So I want to compare stats from Team 1 versus Team 2. So we're just going to pull the stats from this sheet for each one of those teams and compare them. Okay, so first thing we need to do is figure out what those pairings are. So we're going to call this... we're going to call this seed dictionary. I have caps locked on here. This is going to be equal to seeds. If you let me just display seeds to show you what it was. Seeds was one we imported way up at the top. Okay, so you can see seeds is what year it is, what the seed is, and then what the team ID is associated with that seed. This is actually a good time to explain the seeding. Sorry. So in the bracket, there are 4 quadrants, and in Kaggle has put them down as X, Y, W, X, Y, and Z. So each of the 4 letters refer to each one of the different quadrants, and in each one of the quadrants, there's a ranking of 1 through 16 for those players that are in that conference. So each one of the conferences has 1 through 16, and then the winner of each conference comes together, and then they compete, and then the final champion is the winner of the 2 conference titles. So when you see these W's or Z's or X's or Y's, that just refers to which quadrant it is. I don't really care. I just want to know what your seed number is. So we're going to basically just ignore the letters, and we're just going to take the values. There's also a chance that when the 2 conferences start competing against each other, there's going to be like 2 16 seeds or 1 seeds or whatever going against each other. So they're going to call that like W16A and W16B to show that there are 2 16 seeds going against each other and to distinguish between which one is which. I also don't care about that. I'm just going to say they're both 16. Just to make it easier. So let's go ahead and start pulling that apart. So again, we're going to call this seed dictionary. It's going to be equal to seeds.set index. I want the index to be equal to the season first and then the team ID to match what we did up here with the season and the team ID. Just because it's going to make it easier for us to reference each one of these for the years that we care about. So go ahead and pass in season and pass in team ID. Okay, so that is going to change if I display seed dictionary. Okay, that is only going to give us the seed on the right hand side, and then we have the season and the team ID to reference that. Now we are going to need to take care of those seed values, but we'll do that in a second. Like before, where we had the regular season input, now we're going to have the tournament input. So we're going to call that one tourney input, and it's going to be equal to pd.dataframe. Go ahead and just make an empty data frame. Okay. Let me display one more thing for you to just jog your memory real quick. I'm going to display tourney compact. Again, another one that we imported up top. Okay, now tourney compact, if you remember, was what season it was, what day number the match was on, who the winning team ID was, losing team ID, how much the winning team scored by, and losing team scored by, blah, blah, blah. So all of this, okay, so if you think about us predicting the March Madness bracket that's about to happen in the next couple of days as of this video, we are not going to know any of this information because we're going to be predicting into the future rather than having any of this. So I don't care about any of these scores or anything like that because I won't know that in the future. So go ahead and just completely ignore that. What we do care about is the past data. So I want to know the season. I want to know who the 2 team IDs were, so the winning team and the losing team, and that's about it. So we're going to go ahead and just extract all of that. I don't really need to display that anymore, so I'm going to get rid of that. Okay, so I need to know the, like before, if you remember, or I'll just look back down here. Okay, so winning team ID and losing team ID, but that doesn't tell me when my, like in 1985 team 1250 played against them. But if I only pull the winning team ID, I won't be able to see the losing team ID. So I need to merge them again, like we did in the last one. So I'm going to call these win IDs. That's going to be equal to tourney compact at, we scroll down, that's W team ID. Okay, so that's going to pull all of the winning IDs. But now we need to also pull all of the losing IDs. And this could be the L team ID. Okay, so that gives us all the winning and losing teams. I also want to preserve, like I said, this season. So I'm going to call this season. I just realized I spelled compact wrong in both of these. So go ahead and fix that if you copied me. And then we're going to call this season. We're going to pull the season column. Okay. Now, this gives us all the IDs and losing IDs and the seasons. But now we need to actually pull what those winners were. So like we did up top, we're going to have something called winners. That's going to be equal to just an empty data frame. ed dot data frame. Okay, so now we're just going to construct it the way we want it to be. So I'm going to have 3 columns. I'm going to have the season, because I care about what year it is. I'm going to have team 1, and I'm going to have team 2, because I do not care which one was the winner. I actually don't want to know which one the winner is, because that would bias my model to always pick. If I always put the winner as team 1, the model is just going to learn pick team 1. So don't do that. Okay, oh, sorry. Also, I need to double bracket this because we're referencing multiple columns. We're making multiple columns here. Okay, so tourney compact. Okay, tourney compact is going to be season, W team ID, oops, and L team ID. So just passing in those columns. If you remember down here, season, win team ID, lose team ID. And those are going to give us all the winning teams in team 1. Now we're just going to do the opposite and grab all of the losing teams. But actually first, I do want to preserve which one were the winners so that we know what our output should be. So we're going to say winners is going to be... Oh, sorry, we're going to make another column called result. So winners at result is going to be equal to 1, which means what I'm really trying to do is I have 2 team IDs. You have team 1, team 2. I want to know for my output, the thing I'm trying to predict, whether or not the first ID won it or lost it. So every time the first ID won, we're going to give it a 1. Every time the first ID lost, we're going to give it a 0. You're going to see in a second if I just copy all of this. We're going to do the same exact thing, but we're going to have all these losers. Go ahead and change winners to losers. Okay, so losers is going to be the same thing. We're going to have the season. We're going to have team 1 and team 2, but now we're going to switch team 1 and team 2 based on which one we're passing it. So instead of passing it win team ID, we're going to pass it lose team ID first, and then we're going to switch it and put win team ID next. Now, since the losing team is going to be in the first position, the first team in here, and we're trying to predict whether the first team wins it or not, we need to change this to a 0 because they did not win it. The team 2 in this circumstance won it. Okay, so that gives us winners, losers, and now just like before, we're just going to say tourney input is going to be equal to pd.concat winners and losers. Okay, that's going to give us a combined, if I just display tourney input. Let me clean this up. I don't need to see the seed dict right now, so I'm just going to get rid of that. Okay, but as you can see, we have the years, we have the team ID versus the second team ID, and then the result of the match in reference to whether team 1 won the match or not. Perfect. Exactly what we want. Now, one thing that you may notice is these go all the way back to 1985, but the data we have up here stops at 2003, or starts at 2003, I suppose. So we really just need to match those up. So I'm going to say, we're going to say tourney input is going to be equal to tourney input at tourney input, the season column. So I want to know where the season column is equal to greater than equal to 2003. Okay, so that is going to chop the bottom off. Now we just need to reset index drop equals true. This is just going to re-index all the values. Don't use a bracket here, use parentheses. This is going to reset all the indices to be 0 to however many we have. run it, capitalize the T in true. Okay. As you can see, now it starts 2003 up to 2021. So this is perfect. This is what we want. All right. So one other thing we need that we don't have in the other data because it was for the regular season, and it would be super useful, and it probably correlates strongly with whether or not the team wins or not, is what seed that specific team is. So if the one team is playing the 16 seed, then there's probably a strong chance the one seed is going to win that. Not always. Definitely there's upsets in all of these tournaments, but we need to know what those seeds are. And that's where that seed dict comes in. So just make some space here. So I need to keep track of two things. I need to take the team 1 seeds, and I need another one for the team 2 seeds. Now I'm just going to have to do a for loop. So for x in range length of tourney input. So we're just going to step through row by row in this data frame and figure out what those seeds were by using that dictionary that we put together. So IDX, you look up here. I know I didn't need it before, but now I do. So seed dict. I'm going to say dot columns dot values. So I'm printing out the, oh, sorry, not columns. I need the index. Okay, so print out the index of the seed dictionary. And just to run this a second, I'm just going to throw a pass in here. Okay, so as you can see, the index, since we have it indexed on the, if you go back up this one, the season and the team ID, it's the same thing for the seed dictionary. We need to pass it in 2 indices in this tuple right here. First is the season. Second is whatever ID we care about. So we need to replicate that. We're going to do that using, we're just going to make a variable called index. And we're going to make a tuple. So use a parenthesis and say tourney input. Again, the first thing is the season. So go ahead and pass in the season at X. So at whatever row we're at. And do a comma. So that takes care of the first one. And then we just need to say the tourney input at. Now, so we need to do this for both team 1 IDs and team 2 IDs. So go ahead and start with team 1 ID at X. So that is going to give us what the index is looking for. The year followed by whatever team ID that we're trying to get. Now we need to pull the seed. So we're going to say the seed is going to be equal to the seed dict. We're going to have to locate those indice values. So we're going to locate IDX. And then we're going to want to return the values. And we only want the first one because there should be only one value and it's going to put it into a list. Let me just print seed to make sure that we are doing this right. Okay. As you can see, it's pulling all of our seeds. Now here's an example where there were 2 16 seeds. So there's an A and a B. So this one is 4 characters long, while all the other ones are normally 3. So again, something we need to take care of. And we also don't really care about any of the letters. So we only want the numbers and we need to convert it to an integer. So let's just go ahead and make an if statement that just takes care of each one of these. So if the length of seed, so if the length is equal to 4, so if there's 4 characters in it, then we need to say the seed is equal to the integer value of the seed from position starting at 1 all the way till 1 from the end. Because we're going to ignore the first one and we're going to ignore the last one. We only want the middle two. And we're going to convert it into an integer. And else, so all the other ones are 3. So we're just going to say the seed is equal to the integer value of seed from 1 on. So just ignore the first one. These are brackets. Okay. So that will take care of converting the seed to an integer. Now we just need to pass that back. So team 1 seeds dot append pass it in that seed. Okay, so this takes care of all of the team 1. Now, go ahead and copy every single thing we did here because we're going to do the same exact code but for team 2. So go over here, change this to now be looking at team 2, still passing it into the dictionary, still doing all this conversion, but we're going to be appending these to team 2 seeds. If you want to make this a little more efficient, go ahead and make this a function. I don't really care. I'm just going to run this and it should compile fairly quickly, so it doesn't really matter. Now that we have all of our team 1 and team 2 seeds, we need to pass that into our data frame. So tourney input, we're going to make another column. This one's going to be called team 1 seed. It's going to be equal to team 1 seeds. And I'm going to copy that because same thing for team 2. Team 2 seed is going to be equal to team 2 seeds. Running that. I'm still printing out something up here. I'm just printing out the index. Don't need that anymore. Okay. Now this is looking better. We have the season. We have each of the team IDs. We have the result, which we're going to pull out, and that's the thing we're going to be predicting. And then we have the seed that's for the first team and the seed for the second team. Perfect. So that takes care of all of the information that we really need to understand for the tournament. Now we need to combine both of these data frames, one for the regular season, one for the tournament, into one data frame in order to use it for testing. Now, like I said before, what we're going to be doing is we're going to be taking the regular season information, all the stats that we calculated up top here, all of these stats. We're going to be pulling the information for the Team 1 ID and the Team 2 ID, and we're going to be comparing those in order to make a prediction of which one was stronger and which one's more likely to win. So one way of comparing those is to just subtract one from another. So in this case, I'm going to subtract Team 2 values from Team 1 values, and that is going to be our input into the model. So let's do that right now. I'm going to make another cell down here. Okay, so I don't know what to call these. We're just going to call them outscores, whatever our output scores are. So it's going to be a list, and we're just going to do a for loop, again, kind of like what we just did, running through each line in the data frame. So for X in range, length of tourney input, so for each row in the tournament input, we are going to be pulling information for both of those IDs, converting it into the difference between the two. Okay. Like we did up top, we do need an index because if you remember, scrolling all the way back up top, we have two indices here. We have the season followed by the team ID, so we need to pass both of those in. Same exact thing that we did in the other one. So we're going to make a tuple. First thing is going to be tourney input at season at X, so whatever row we're at. Next is going to be tourney input. We're going to start with team 1. So it's just going to pull the ID for team 1. And that is going to be our tuple. Make sure you are taking the row and not passing in the entire thing. Okay, so that is going to be the tuple that we're going to pass in. So now we're going to say team 1, we're just going to call this score, is going to be equal to regular season input. We're going to locate that IDX. Okay, so we're just going back up to this data frame here, and we're finding where the season and the team ID are equal and polling how they did that specific season. Okay, so that's for team 1. Now, one thing I need to add to here is I need to add that seed that we just calculated. So team 1 score, we're going to make another column called seed. And this is going to be equal to the tourney input, the latest data frame that we made at team 1 seed at X. Okay, a lot of stuff going on there, but basically what we're doing is we're referencing the regular season input. We're pulling that line from the data frame, They were adding in whatever seed they were from where we calculated it right here. And that takes care of all the values for team 1. Go ahead and copy all 3 of these because we're going to do the same exact thing for team 2. Everywhere it says team 1, change it to team 2. And now we have we have to change the variable as well, so make sure this says team 2 scores. And now we have the information for team 1 and team 2. Now we just have to subtract the 2. So we're going to say outscore is equal to team 1 score minus team 2 score. So we're just taking the difference between the two teams and using that for our output. That takes care of our input data. Very last thing we need to do is we also need to know, since we're doing supervised learning, we need to know what the model should be fitting to. And that is going to be this results column, whether or not the team won the game or not. So we need to add that onto it. So outscore at result is going to be equal to tourney input at result at row X. That will give us our entire complete row. Now we need to do that for every single row in here. So I'm going to append that. So outscore, we're going to append that into outscores. And that is just going to give us a list of single line data frames. So we can just convert that into one final data frame at the very end. We're going to call this outscores. We're going to say pd.data frame and pass it in outscores. And now we can display outscores to see the final result. Hopefully I don't have any errors. Let me run that. This one may take a second, but it should go fairly quickly as well. Yep. Okay, so you can see there's some negative values because one team was stronger than the other. So a lot of this we would like to see. I'm just going to do a .describe. Again, this may take a second to run. I'll just display both actually, just in case we need to do it again. I don't want to slow this down at all. Okay. If I go down here to the .describe, you can see the minimum values, the maximum values. For some reason the mins and the maxes are equal to each other, but that's not the case looking at here, so not sure what's going on there. Doesn't really matter. What would matter is I would like to know which one, which of these ratios actually matter a lot or are heavily correlated with predicting the output. So if I make another line here, we can actually do that. We're going to call this cores for correlations. That's going to be equal to, we're going to round this. So round outscores dot core. There's an automatically built-in function called core for correlation. We're going to round this to 2 decimal places. And we're going to, I just want to display these. So go ahead and just display cores. Okay, so before I do this, there are 2 things that will happen here. Some variables will be, well, I guess 3 things. Some variables will be super negatively correlated. So they're going to be all the way down to -1 as the max, or something that's super negatively correlated, or something is going to be super strongly correlated. That's going to be closer to 1, or something's just in the center and it's not really correlated. So it's going to be closer to 0. So what I'm going to do, I don't care if it's negatively or positively correlated for this, because I want to just know what is correlated. I don't care if it contributes or negatively contributes, because I can just do the, if I were to make a prediction on something that negatively correlates, I'll just do the opposite of whatever that's doing. So I'm going to do an mp.abs, so absolute value of the correlations that we just calculated. Now, I do not care. This is going to do the correlation to between every single variable in the data frame. I do not care about every single variable in the data frame. The only one I actually care about is the results, because I want to know what is correlated to the thing that we're trying to predict. So you can go ahead and display that. Okay, like I said, anything that is closer to 1 is strongly correlated. So obviously if you go down here, the results are 100% correlated with each other because it's the same thing, obviously. So we're just going to kind of look at, since we're doing the absolute value, just looking for high values. So win ratio, that's pretty high. So 0.34, we got a 0.42 for the amount of points scored, or the point ratio. So yeah, that makes sense. All these other ones are kind of middle of the road. Seed is definitely correlated. So there's some higher ones in here. You can kind of get a sense for what the model might be looking at. But even if you just do your analytics by yourself, those are three fairly highly correlated ones. So we should be able to get some results out of this. Another thing you could do is actually you can just visualize this. So I'm going to import Seaborn. I've used this in at least one other video. But this is just another data visualization tool. Typically, it's imported as SNS. If you don't have this downloaded, go ahead and download it, or it's not a big deal. You can just watch my screen. But we're going to do a plt.figure, fig size. It's going to be equal to, let's make it 15 by 10. Okay, so sns.heatmap. We're going to pass in those correlations that we just calculated, and then just do a plt.show. The reason I'm using PLT, so the matplotlib pyplot, is because SNS uses pyplot as a backbone. So go ahead and run that, and then this is just going to give us a heat map of all of these correlations. So you have this very colorful chart. Now, what are we looking for? Well, we are really looking for where these values are either really bright, so up here where it's closer to this white color, because that is a highly positive correlated variable. And then down here at the bottom is really dark, right? So that's super negatively correlated. So all of these show you against each other. Maybe if I zoom out a little bit, this will help. You can see all of the features and then the ones that are being weighted against. Obviously, when you weight them against them, or when you correlate them against themselves, it's going to be 100% correlated. So what we really care about is the results line. Either look at the row or the column. Doesn't really matter, but we're looking for any values that are brighter or darker. So looking at it, win ratio, that one's pretty bright compared to the other ones. Definitely point ratio is bright. All these other ones are kind of middle of the line until we get to seed. Seed is super dark, and again, that was one of the strongest correlated when we looked up in this list. So just a way to visualize your correlations of all your different features. As you start adding more, maybe you find some are more correlated to it than others. But that's where I'm going to stop for just looking at this. Now we're going to let us go ahead, and I guess we're going to just start making our data. So we need to split up our data into the X and the Y components for predicting the data. So we're going to say X is equal to outscores. Remember, outscores is that data frame that we just put together. I want to take all of the columns except for that results column, and I just know the results column is the very last one. So what I'm going to do is I'm just going to pass it in outscores dot columns. I only want the columns all the way up till the very last one, or one from the end. So all the way up till -1. And I'm going to do a dot values because I just want the values. I don't want to keep it in a data frame. So that will give us all of our X values, and the Y values are going to be equal to the outscores at result. And again, dot values because I do not want to keep it into a data frame. Okay, this gives us X and Y values. Now we need to split this up into training and testing sets. Now, since we're individually doing each one of these, it does not matter to keep it year by year. If you want to, you can. If you want to just hold out 2021 and see how you would have done, you can do that. I'm actually just going to mix these up and then just pull out randomly 20% as my testing because it doesn't really matter. So I'm going to do an np.random.seed. I'm just going to pass it in 1. I'm doing this because I want you to be able to repeat everything I do here. So anytime I use a random value, I'm just going to fix it. So I'm going to say IDX is equal to np.random.permutation I'm going to pass in the length of x. All right, so what is this doing? Well, permutation is taking, in this case, the length of x, so all of our inputs, and it's just randomly mixing them up. One of the problems with our data set right now is all of the ones are on top for all of the wins, and all the losses are on the bottom for zeros. So we're just going to randomly mix these up, and then we're going to go ahead, and from that, we're going to pull out our training and testing indices. So train IDX. Like I said, I'm going to use 20%. So we're going to say IDX at everything up until the integer value of negative 0.2. So 0.2, again, 20% of the data. So 0.2 times the length of x. And I'm passing it into, I'm doing it negative because I want to do everything up until that point. And then I'm also converting it to an integer because we're referencing the indice. It needs to be an integer. This will just automatically round it for us. Okay, so that takes care of the training index. If you want to use something like train test split and sklearn, that's easier as well. I just kind of like doing this just because it's useful to see how you can actually do it on your own rather than just allowing sklearn to do it. And then the test index is the same exact thing, except for it's everything from that point on. So just swap where that colon is. Okay, so now we can say x train is equal to x at those training indices. X test, same thing, but we're passing in the test indices. Y train at the train indices. And y test is equal to y at the test indices. Great. Now let me print xtrain.shape, xtest.shape, ytrain.shape, ytest.shape. I just want to make sure we have the same amount of data in each one of these, and we can see kind of what our split is. So we have 1,890 training points with 22 features, 472 tests, and you can see those match as well. Okay. Next, what we should do is, let me scroll all the way back up here. Okay, so we have a lot of these values, and some of these are super small, some of them are super large. So what we really want is to normalize these between 0 and 1. So if we scroll down to the bottom here, we are going to say, we're going to make two variables. One's going to be called mins, and it's going to be equal to the x train. It's very important that you do this on the training data, and you do it after you split your training and test data. If you leave your test data in here when you take the minimum, you're leaking some information about your test distribution to your training, to your model. So you need to do this after you split the data and apply what you learned from the training data onto the test data instead of the other way around, or instead of including both of them. So we're going to do the training dot minimum. We're going to say where the axis equals 0. So this is going to just take the minimum of each one of those different features. We're going to do the same exact thing for the max. Go ahead and copy that down. We're going to say the maxes is equal to the same thing, but just the max. Okay, this is min-max scaling. So again, you could do this with sklearn, but it's also cool to just do it yourself. So we're going to call this xtrain is going to be equal to xtrain minus the mins divided by the maxes minus the mins. This is the equation for min-max scaling. So that takes care of the x training data. Go ahead and copy this down here. We're going to do the same exact thing for the testing data. And go ahead and swap each one of these names to say test. Now, again, this is taking the mins and maxes from the training data, and we're going to be applying that same scaling using those values to the testing data. This is not a capital T. Okay, so running this one more time just to make sure. Okay, now we have our normalized input, and we are ready to go ahead and feed this into a model. So I'm going to say from sklearn dot ensemble. We're going to be importing random forest classifier. So we're going to use the random forest to predict this. If you haven't seen the video I've done in random forest, I explain high level how this works. Quick video if you want to go check that out. Definitely recommend it. But let's go ahead and make our model. So we're going to say random forest classifier. I'm going to, again, pass it in a random state equal to 1 because I want you to be able to repeat everything I've done here without any randomness getting in the way. We're going to say model is equal to model.fit. We're going to pass it in the training data. So xtrain and ytrain. And then I'm going to do a model dot score, xtest and ytest. Running that. Okay, we have our model doing 69%. So our model is almost 70% accurate in predicting whether or not Team 1 will beat Team 2. So that is actually fairly good. It's better than a coin flip. So there's definitely something there that the model is able to base this off of. Now, we could do other things. We could try different models. We could try different set of hyperparameters for the random forest to try to up that accuracy. But what we really need to do, and what is going to get the biggest amount of boost in this accuracy, is we need to go back up and we need to find more data to use. There's a lot of things that I did not add in this data set. For instance, I didn't add anything about past performance in tournaments. I didn't add, there's a whole bunch of different statistics for like how strong a team's season, or how strong their competition is. I didn't do anything with their conferences. Actually was going to, and I forgot to add that into this one, but that's all right. So I didn't say what conference they belong to and if they're in one of the Big Ten conferences or anything like that. So there's a lot of other data that's out there that I did not add. Like I said, let me open this tab up again. There is a ton of other information that Kaggle provides to you. They also provide this last one here. This is probably the most useful of all of them because they list common spellings of each one of these because there's a ton out there of each one of the team names. And that's going to be super important if you go out and grab external data sets because they won't have those team IDs. And so you're going to have to convert names into team IDs in order to reference each one of these. But there's things like coaches in here, and then there's other tournaments information. So there's a ton of stuff in here. There's rankings. So again, ton of other stuff that you can add here, and they may be strongly correlated and get you better results. So definitely go check out those other data sets. Look for external data sets if you want to prove upon this. If you're watching this relatively quickly after I release this, the seeds are actually about to be released. So instead of doing this to predict the 2020 data, go ahead and just put in those new seeds, put in the new information for 2022, and you should be rolling to predict your next bracket. So what you're gonna have to do is you're gonna have to figure out those seed pairings. You're gonna have to put both of those teams in, do the difference. That'll give you which one's the winner, and you just keep doing that all the way down to the championship and just fill in the bracket. You can fairly easily make a script to automate each one of those steps, but I'm not going to cover that. If I have time to work on it before the games start in a couple days, I'll try to put something together, but for now, I'm just going to stop right here. I meant this as a introduction to how you could use machine learning to predict the March Madness brackets and just kind of beginner's guide to how to do some sort of stuff like this. So I hope you guys got something out of this. Definitely stay tuned. If I do release that other video, I'm not sure if I'll have enough time or not. But maybe next year I'll do much more in depth and try to get the model performance way higher to actually compete in this competition. But for now, thanks for joining me, and until next time.